In this video, we are going to evaluate z divided by z minus 1 into z plus 1 all squared. So we are told to evaluate this function here. So, and this is f of z. F of z is equal to this. So to evaluate this, first of all, let's look at the denominator. We are going to take this to be z minus 1 into z plus 1 all squared equal to 0. We equate the denominator to 0. And if we equate the denominator to 0, solving this now, we are going to have z minus 1 to be equal to 0. That we are going to break this into two halves. Then z is going to be equal to 1. Then at the other side, we are going to have z plus 1 all squared equal to 0. And if you take the square root of both sides, you are going to be left with z plus 1 equal to 0. Then that means z is going to be equal to minus 1. So we have z to be equal to 1 and we have z to be equal to minus 1. Now let's look at the pole. This is the pole, this is pole z equal to 1 and this is another pole z equal to minus 1. Remember, we have something like this, z is equal to a. This is a here. That means this a now means z is equal to 1 and minus 1. Now let's look at the order of each pole here. Now when z is equal to 1, we know this is what gave us z equal to 1. We discover that the order here is 1 because this is raised power of 1. So at z equal to 1, we have order 1. And also let's look at z equal to minus 1. This is what we have here, and if you check here, the order here is 2, is raised power of 2. So at z equal to minus 1, the order is 2. The order is 2. Now we are going to input these two, z equal to 1 and z equal to minus 1 in our formula, where we have a minus 1. This is minus here. We have a minus 1 to be equal to, we have limits as z turns to a, multiply 1 all over, let's use the pole here to be m minus 1, multiplying the m minus 1 divided by the zm minus 1. This is supposed to be a factorial here, into, we have z minus a raised power of m, multiplying f of z, the function itself. So this is what we have. Now at z equal 1, at z equal 1, order 1. Now let's look at what we have. Then this is going to be limit as z turns to 1 now, 1 divided by 1 minus 1 factorial, where m is equal to 1, that is the order. Then you have the 1 minus 1 divided by the z1 minus 1 into z minus 1 raised power of 1. This is order 1 here, multiplying the function itself, which is z all over z minus 1 multiplying z plus 1 all squared. So solving this further now, let's take it up here. We are going to have limit as z turns to 1, and we are going to have 1 all over 1 factorial. So 1 over 1 factorial is 1. So we are just going to have this, and also d raised power of 1 minus 1, we are going to have 0, and we are going to have 0 here, and you know everything here will turn to 1. So we'll just be left with this into z minus 1 multiplying z all over z minus 1 into z plus 1 all squared. So that means we have z minus 1 here, we have z minus 1 here. These two will divide each other. So you now be left with limit as z tends to 1 into, you have z divided by z plus 1 all squared. So if you substitute this limit now, let's take our limit. We are now going to be left with z. It will not be z now. We are going to be left with 1. Substitute that limit, we are going to be left with 1 divided by 1 plus 1 all squared, which is going to be 1 all over 2 squared, which is equal to 1 all over 4. So that's what we have there. So now we are going to also solve for, you remember what we solved here was at z equal to 1 order 1. Now we are going to solve at z equal to minus 1 order 2. So at this point now we are going to have limit. Substituting that here now, we are going to have limit as z turns to minus 1 into 1 over 1 minus 1. Sorry, this is 2 now, into 2 minus 1, because order here m is equal to 2. This will be 2 minus 1. Then we are going to have multiplying the 2 minus 1 divided by the z2 minus 1, and this is into z minus here, because we have minus, sorry, because we have minus 1 here, that minus we're going to have plus 1 here squared. Then this is multiplying the function z divided by x minus 1, sorry, z divided by z minus 1 into z plus 1 all squared. So let's look at this now. You know that you have z plus 1 all squared here, z plus 1 all squared here. That means these two can divide themselves. So you'll be left with limit as z tends to minus 1 of, and this is 1 divided by this factorial here. Then this is 1 divided by 1, which is 1. Then the whole of this will be left with the z into z over z minus 1. So this is what we have. So what we are going to do here is that we are going to differentiate this function here and substitute the value of minus 1. So if we differentiate that function here, we are going to have limit as z turns to minus 1 into, you keep the denominator here constant, which is z minus 1. Differentiate the numerator, you are going to have 1. Then that is minus. You now keep the numerator z, differentiate the denominator, you have 1. Remember, this is differentiation of quotient rule. This will divide z minus 1 all squared. So you are going to have limit as z turns to minus 1, as z turns to minus 1 into, this is z here and this is minus z, so that will go, you will be left with minus 1 all over z minus 1 squared. Now let's input our limit now. If we take the limit, we are going to have minus 1 all over minus 1 minus 1 all squared, which is going to be equal to minus 1 all over 4, because this is going to give you minus 1 all over minus 2 all squared, which is going to give you 4 here. So this is your answer. So this is the answer to this question. You have this place to be 1 over 4 and you have this place to be minus 1 over 4. Please like this video, share it with friends, and don't forget to subscribe to this YouTube channel and hit the notification bell to get notified each time we upload a video. Thank you.